Welcome back. So as we said, we start with Rhino, a brief introduction on the software, and I will explain you why I suggest you to use that. As I said before, that's not mandatory. You can use the software you prefer. It's just to, give you a suggestion and eventually allow you to explore different things that you haven't tried yet. So Rhino is very flexible and useful when you want to work with machines, because on one side it allows you to handle 2D files, 3D files, surfaces, solids, mesh pretty precisely. And all those things are very useful when it comes to deal with 3D printers, laser cutters, milling machines, and all the machines that can be controlled by a computer, the one we will use during the course. So let's have a look at the software. You can easily find it online. You can easily download a trial version, and it should be installed in the computer on the computers in NABA, so you shouldn't have any problems to actually use it. So this is the interface of Rhino. Very simple, very common to many softwares, different views, menus on the side, on the top, and detailed one here. It's quite likely that you will not need to get into too advanced features of the software, but if you need to, you can easily do that through tutorials. It's very easy, it's very fun. Now let's start with the basics. Why I suggest you to use Rhino. So first of all, when you work with the laser cutter and even with milling machines, it's fundamental to be able to draw something precisely. Precisely, it means not just, be sure that things are perpendicular, but also with a precise dimension. We will get into how to do that, but just to give you an example, if I want to have 100 millimeters horizontal line, I can do this, and I'm sure that this line is going to be 100 millimeters long. Now, precise mechanical, or let's say precise technical things is not necessary enough. You have different ways to handle curves and more organic shapes. This of course becomes very useful even to control the point of these curves and so on. As you can see, it's very, very simple to do so. And in some cases, it could be fundamental for your project. Rhino is not as good as Illustrator, for instance, on managing graphics and nice vector design, but you can easily import those in Rhino after you create it, for instance, in Illustrator. So keep that in mind. It could be useful for the first exercise in particular. Now, it's not just 2D. We can easily work on 3D as well, starting from simple solids. Okay. When you select the object, here you have a description of what that object is. So in this case, it's a closed extrusion. We will get to what closed means. But this solid can be, intersect, added, or cut out of other things to create more complex geometries. Let's, see a very basic example. So here I have two volumes intersecting. You see that they are not connected together. because they are two solids, I can use Boolean operation. In this case, for instance, I can join them together. Now they are not anymore two different objects, it's a single one. You notice it following the lines of the isocurves of the surfaces. You see that here it's not going on, while before this operation you can actually see the lines going through the other solid. So this is an example, of course, not the most complex one, but if we want to, we can do even the other way around and just subtract a piece from the previous one. So these operations are very, very common, but also very useful when you want to design something precise and you want, I don't know, cylindrical holes, you want a precise geometry. Now this becomes fundamental. This object here, you see it's a closed solid polysurface. That means that it's a set of different surfaces connected together somehow without leaving any gaps. This is fundamental when you want to 3D print it, for instance. It means that the machine can easily understand what's inside from what's outside, and infill the inside with plastic and leave the outside untouched, as it should be. That's not always the case. So now I exploded the solid, and that brings out all the basic components, all the surfaces that creates it. Now this object can't be 3D printed anymore because the machine can't identify the inside and the outside in a unique, non-confusing and precise way. So because of that, it's now something unprintable. If we join it, we get a new definition now, open polysurface. That means, as we said, that this is not something we can print. There is also a feature to analyze the edge, and that's highlight open borders, so borders that are not touching other borders of the same object. And you see these lines, these pink lines, showing you where the object is open. Well, in this case, it's pretty obvious, but it's not always as obvious as this. So this could be a very useful features and function for you. Now, how can we close this? Well, we can draw a surface on top of this. For instance, a surface made by all the planar curves. So this border here, and we get back the surface we deleted before. Now, technically speaking, this is a different surface than the one before, but the shape is the same and it's touching all the same borders. That means that now if I join everything back together, so using the join command, I get a closed solid polysurface. Now that's exactly what I was looking for, because this object could be 3D printed. Now, this can be treated as a solid, even if it's a combination of surface. And as a solid, you can, I don't know, fillet the edge. Now, the fillets in Rhino are not very good, to be honest. It's not the best feature that you have. And sometimes they make like weird shapes and mistakes. In some cases, it's actually not Rhino's fault. So if I select a chain or like this, and I say try to cut it, well, in this case, it's not easy to cut the thing. Cut with a 10 millimeters radius, something that is actually bigger than the radius here on the corner. This is not easy to cut. Here as well you have the same problem. Here you should get a sharp corner. So it's just drawing the surfaces for you, and then you can decide how to trim the object using the surfaces. Not the best feature, to be honest, but still, you know, if you are patient, you can explode the solid, cut the solid with the surfaces that it creates, and you get the fillet anyway. Now this was done in purpose by me to show you a potential problem. If you have a fillet and the radius is less than the one you want to fillet, then it should work better. And just, you know, cut away the material and give you this nice fillet the way you wanted. Now you see why before it was tricky. Here it can go around without any problems. When this radius is bigger than this, that becomes an issue. Now this wasn't something I particularly care about, but let's say when I have a solid, I can work with the solid features, and sometimes these things are much easier to use compared to the surfaces one. Again, when you want to 3D print this is not going to be enough. These are mathematical surfaces described as Rhino describes it. It's not a universal language, let's say so. To 3D print it, you have to transform it into a mesh. You can do it through a more advanced set of commands or through an easier one. In this case, you just get, you know, few polygons, a lot of polygons, and that's it. You see that where you have round surfaces, you get a higher density of polygons, and when you have less, you get less. Probably a mesh like this could be printed without big problems, but it's not the best one for 3D printers. We will get there when we work on 3D printers. So no worries at the moment. Let's keep it just as a example like this. You see, you still have your solid object, but you also get the mesh file. Now this mesh file could be exported. You know, export selection, you select an STL file, save it, and you get your object. It tells you the way you want it. This is just the way the STL file is written. We'll get to this when we speak about 3D printers, but it doesn't matter really. So pick up the one that it's lighter, that it's the binary one, and you got your file saved. If you don't want to, if you don't want to have that part, you can directly export this. When you try to export it as an STL, it tells you you need to convert it into an STL. So you got the same thing as before. You see that in this case, with these parameters, you get a different result. But basically the concept is the same. And when you say OK, it's gonna export the STL file and the mesh file without creating it. So as I said, it gives you a bit of freedom to work with solids, work with surfaces, work with 2D lines and 2D design, work with mesh. It's not perfect for any of these things, but it's pretty good. So give it a try and have fun. Quickly, an example of where you can find a lot of material is this. www.rhino3d.com/tutorial. This is the link of the official page. You find it through the main menu in download and getting started resources. This gives you a lot of material that you can start with. The level 1 manual should be good enough. You need to add your email, but they don't spam you, to be honest. So you can get it for free, and it's very useful for you to follow it. If I remember properly, but I'm not sure about this, all the exercises in the level 1 should be something you can complete in 2 days, so 8 plus 8 hours. Reasonable amount of time to get confident with the software. So this is it. Next video is gonna be about the basics on 2D design, and then we'll see some exercises. See you later.